Welcome to this explainer. Did you know Java was actually designed for interactive TV way back in the early 90s? Well, it turned out to be a bit too advanced for cable boxes back then, but today, it literally runs the world. Today, we're going to demystify Java. We'll be exploring its massive power in the world of enterprise applications, backend development, and big data technologies. But most importantly, we're going to set you up to write your very first lines of code. Whether you're aiming to become a backend developer, a software engineer, or you're just dipping your toes into programming for the very first time, you are in the exact right place. Here's our roadmap for today. We'll kick things off with a welcome to Java, compare it to some of the other tech giants, decode all that Java alphabet soup, get your environment set up, write your very first program, and finally, look at how Java actually runs under the hood. All right, Section 1, Welcome to Java. It's time to understand exactly what this language is and where it came from. To really wrap your head around Java, you've got to understand its core philosophy. Write once, run anywhere. Java is this high-level, general-purpose, object-oriented language that was originally cooked up by Sun Microsystems and is now maintained by Oracle. But here's the absolute game changer. That famous mantra perfectly captures how Java completely solves the headache of cross-platform execution. By compiling code into something called bytecode, which we'll dig into a bit later, massive banking systems, cloud applications, and web backends can be written on one single machine and then executed seamlessly on literally any other device that supports Java. And Java comes absolutely packed with heavy-hitting features. As we just mentioned, it's platform-independent, it's heavily object-oriented, leaning on concepts like classes and inheritance. It is robust, it's incredibly secure, and it's multi-threaded, meaning it can juggle multiple tasks all at the same time. But honestly, here is the best part. Automatic memory management. Instead of you ripping your hair out trying to manually allocate and free up memory, Java uses this thing called garbage collection to handle all of that automatically behind the scenes. It is a massive headache saver. Throw in a huge ecosystem of libraries and frameworks like Spring Boot, and it's no wonder Java is so insanely popular. Moving right along to Section 2, comparing the tech giants. So, how does Java actually stack up against the other programming heavyweights? Look, there's no universally best programming language out there. Different languages simply serve different purposes. Python, for instance, is dynamically typed and super beginner-friendly. It is the undisputed champ for AI, data science, and automation. C++, with its native compilation and manual memory management, totally dominates systems architecture and performance-critical gaming. But look at Java right there in the middle. With its statically typed nature and JVM execution, it is the go-to king for backend enterprise apps and the Android ecosystem. Plus, learning Java teaches you vital object-oriented concepts that will seamlessly carry over to almost any other language you want to learn later. Next up, Section 3, the Java alphabet soup. If you're new to the Java world, you're going to get hit with a ton of three-letter acronyms. So let's clear them up right now using a nesting doll analogy. Right at the very center, the smallest doll, is the JVM, or Java Virtual Machine. This is the exact environment that acts as the absolute engine of the whole operation. It takes that translated middle language we call bytecode and actually reads and executes it on your specific local machine or operating system. Without the JVM, your computer would literally have no clue what to do with a Java program. Stepping up a layer to our next nesting doll, we have the JRE, the Java Runtime Environment. This simply takes the JVM and wraps it up with a bunch of necessary runtime libraries. Basically, if you're just a standard end user and you only want to run a Java program someone else has already built, the JRE is the only thing you need installed on your machine. And finally, the outermost doll, the JDK, or Java Development Kit. Now, this is the crucial one for us today. The JDK includes all those runtime components of the JRE, but it tacks on the development tools you actually need to write and build your own applications. The star of the show here is the compiler, known as Javac. So, the huge takeaway for beginners. If you want to be a developer and actually create Java programs, the JDK is what you absolutely must install. All right, Section 4, setting up your environment. Now that we know we need the JDK, let's actually cross the threshold and get your local development environment set up. It's pretty straightforward, though the exact clicks might vary a bit whether you're rocking Windows, macOS, or Linux. First, you'll just download a long-term support or LTS version of the JDK from a trusted vendor. Run the installer, and then to make sure everything worked, you'll open up your terminal and type java -version. Remember, the Java command runs the apps. After that, you'll type javac -version just to make sure your compiler is also locked and loaded. Once that JDK is installed, you're going to need a place to actually type your code, an editor or an IDE. You've really got two main routes here. On one side, there's IntelliJ IDE, which is an absolute powerhouse, custom-built specifically for Java. It gives you incredible out-of-the-box features like built-in code completion, debugging, and project management. On the other hand, you've got VS Code. It's a fantastic, flexible option that can do almost anything, but you will have to manually configure it by adding specific Java extensions. If you're an absolute beginner, pick one, stick with it, and just learn the ropes. Let's get to the fun part. Section 5, writing your first program. Environment configured. Let's get that initial win and write your very first program. We're going to create a file called main.java, and here it is, the legendary Hello World application. Looking at the structure, we've got public class main wrapping the whole thing using those curly braces to define the body of our class and method. Inside, there's our entry point, and finally, the actual instruction, system.out.println hello world, which is the command that just prints text straight to your console. Now that middle line is a serious mouthful for a beginner, so let's break down exactly what public static void main string args actually means word by word. First up, the word public. This is what's called an access modifier. It simply means the JVM can access this method from outside the class to kick things off. Think of it like an open door, allowing the system to start your program. Next is the keyword static, and this one is super important. It dictates that the method belongs to the class itself, rather than an instance of the class. In plain English, it means the JVM doesn't have to go through the trouble of creating a brand new object of your main class first just to run the method. It can just run it directly. Then we have void. This keyword tells us the return type of the method. In this specific case, void means the method performs an action, like printing to the screen, but it doesn't return any actual data value back to the system once it's done running. Now, for the word main. Interestingly enough, this isn't some special reserved keyword in the Java language itself. Instead, it's just the universally accepted conventional name for the entry point. Whenever Java launches an app, it's actively hunting for a method specifically named main to start executing your code. Finally, inside those parentheses, we have string brackets args. This is simply an array of strings designed to catch command line arguments. It's kind of like tossing specific ingredients straight into your program's funnel the moment you start it up. For example, if you ran your program from the terminal by typing java main hello, that word hello would get passed directly into the program through this args array. We'll explore that a lot more in future explainers, but that's the gist of it. All right, section 6, how Java actually runs. Okay, we've written the code, we've broken down the syntax. But to truly get Java, you need to see exactly what happens under the hood when you hit that run button. Picture the journey of your code like a translation pipeline. Step 1, you start with your human-readable source code in main.java. Step 2, you run it through the compiler using that javac command. Step 3, the compiler translates your code into bytecode, saving it as a main.class file. This bytecode is that universal middle language we talked about. Step 4, the JVM steps in and reads that bytecode. And finally, step 5, the JVM interprets and executes it perfectly for your specific operating system, giving you your output. This exact architecture is the main reason Java can run seamlessly across entirely different operating systems. So let's do a quick recap. Java is this massive, powerful, object-oriented language. You install the JDK to get your development tools, your source code gets compiled by javac into bytecode, and then the JVM steps in as the environment to run the whole shebang. You've got the foundation down perfectly now, which sets us up beautifully for our next explainer, where we'll dive right into variables, data types, user input, and basic syntax. Before we wrap up, I want to leave you with a thought. You've taken the first big step. You've successfully written and run Hello World. But the true, absolute power of Java lies in object-oriented design, the ability to take real-world concepts and model them right in your code. So as you stare at that clean slate in your new IDE, ask yourself, are you ready to start building your very first real-world digital object? Think about what you want to build, and I will see you in the next explainer to help you make it happen.